One of the most fundamental questions one can ask is, where did it all come from? Why are all the things around me the way they are? Different cultures have come up with all sorts of wonderful and creative answers to that question. The creation story of many indigenous Australian tribes centres around a giant rainbow serpent, which was sleeping deep underground with all the animals in her belly. Then, when the time came, she awoke and spewed them forth onto the earth, creating the land from her body. The ancient Egyptian equivalents involve a giant pyramid emerging out of dark, motionless water, symbolically representing the flooding of the Nile. They are all beautiful and poetic attempts to understand the world, and most probably weren't believed as literally as we think. We're a bit more rigid about these things in the modern world. The Big Bang is the modern equivalent. The theory goes that the universe was created all at once, in one moment, approximately 13.8 billion years ago. All time, matter, and space were condensed into a single point, and then it exploded, creating the universe we know today. The earliest version of the theory was proposed by Georges Lemaître, a Catholic priest in the 1920s. It is now universally accepted by scientists in the same category as gravity and evolution. That doesn't mean it must be true, but it means it's been thought about a lot by really smart people, and the people who've studied it almost all agree. Let's dive in to the Big Bang. The Big Bang is easy to understand at a simple level. It's a Big Bang. On a deeper level, the idea that the universe started out with a Big Bang is weird and doesn't really make a lot of sense. What went bang? Where did the stuff that went bang come from? And what happened before, and why did it go bang? This is where the term Big Bang gets a bit misleading. The Big Bang is not like the explosions we see in our life or in films. And these sort of questions misunderstand what an empty universe is. Imagine holding up your hands in the air in front of you. In normal conversation, you would probably say there was nothing in between them. The space is empty. But if you think for a second, you'd probably realise, oh, of course, there's air and dust and all sorts of random particles floating in between them. Now imagine you took your hands far away and did the same thing in a vacuum out in space. There would still be some particles, even space isn't completely empty. But ignoring all that, in a perfect vacuum, there would still be light and radiation and gravity waves and force fields, all sorts of stuff interacting between your hands. Now imagine if we get rid of all of that. There's no gravity, no light, no particles, and we're far, far away in empty space. Is the space between your hands truly empty? The answer is no. Even if you hold your hands up in the deepest of space, there is still something in between them, even if all the matter and radiation is removed. There is the universe itself. The blank canvas of space and time still continues to exist and flow between your hands. The Big Bang isn't about explaining where the stuff in the universe came from. It's about explaining how the canvas itself came to exist. And so there wasn't anything before the Big Bang exploded. The Big Bang created time. To ask what was before the Big Bang or caused the Big Bang is like asking what happens before the first page in the book. The question doesn't really make sense. That's not to say it isn't interesting to think about, and there are theories about what might have caused the Big Bang, generally around multiverses, but they're not taken particularly seriously yet. The Big Bang is as early as we know how to go back. So the Big Bang is the moment when all time, space, matter, and energy in the universe was condensed into a single point and then rapidly expanded. At this point, everything was so hot and dense that the normal laws of physics didn't apply. In the same way as when you heat things up on Earth, they turn into fluids and gases. After the Big Bang, everything was so hot, it couldn't really have any real form or structure. Afterwards, over billions of years, the universe cooled and clumped into galaxies and stars, and the rest of the history of our universe occurred. Before the Big Bang, there was no time and no space. Very early in the 21st century, it was pretty obvious that all the galaxies in our universe were moving away from the Earth. While this is hard to work out, it's pretty easy to understand. You point a telescope at the sky and see a galaxy. You then work out how far away the galaxy is and how fast it is moving. There are a bunch of different ways to do this, depending on how far away the galaxy is and what it's made of. However, once we did this, we discovered that almost all the galaxies in the universe were moving away from us. There were a variety of different speeds, some were moving much faster than others, but almost every single galaxy in the universe was racing away. This is what people refer to as the universe is expanding. The things in the universe are all getting much further away from each other. Now it's pretty easy to work backwards from here. Galaxies move in a very consistent way. They are not like tissues floating around in breezes on the Earth. They are massive and moving through space, so there's no air and no breezes, so they mostly move in pretty predictable ways. Therefore, if a galaxy is moving away from us, we just wind back time and see that all galaxies must have been in pretty much the same spot a couple of billion years ago. Working backwards, if we know how fast they are moving and how far they are away now, we can calculate how long ago that time was, and it was about 13.8 billion years. This evidence gets you most of the way to the Big Bang. Even with this, it's pretty clear that most of the stuff in the universe was in about the same place 13.8 billion years ago. There are a lot of other pieces of evidence that give you a bit more of the flavour of the Big Bang, in particular the cosmic microwave background that gives you information about how space and time were created. We're going to talk about that more in our next post. But the general concept is the same. By observing what the universe looks like now, and knowing some simple principles about how things in the universe behave, we can wind back time and see without a doubt that everything was very, very close and very hot and very dense about 13.8 billion years ago. So what does this all mean? The Big Bang is weird and wonderful. Perhaps just as weird and wonderful as the giant rainbow serpent spewing forth animals into the world. It answers the same question and raises the same questions about what happened before. Questions about the origins of the universe always will. There are many things to take away from the Big Bang. Firstly, to the best of our current understanding, the universe had a start. And that start was a very long time ago. The universe didn't spring forth fully formed as it was today, and it doesn't seem to go around in loops or cycles. Secondly, when the universe started, it looked very different from how it looks today. There were no stars or galaxies in the early universe. It took billions of years for them to arrive. We're going to talk about that more too. It took even longer for the solar system and our Earth to evolve, and for life on Earth to evolve even longer. Our current universe has been the culmination of a slow process of evolution over billions of years. For much of it, there were no galaxies, no stars, no planets, and no life. And still, in most of the universe, there are none of those things. It's taken us a very, very long time to get here. For us, here at the Universal Story, that makes us appreciate our universe just a little bit more.